Our next skill review video deals with modeling variation. The skill objectives for this particular one are 1. Develop mathematical models for direct variation. Number 2. Develop mathematical models for inverse variation. Number 3. Develop mathematical models for combined variation. And develop mathematical models for joint variation. Conceptual objectives: understand the difference between direct and inverse variation, and understand the difference between combined and joint variation. The one thing to remember with any variation problem is that in any variation problem, one value is going to be a constant multiple of another value. Okay, either that value is going to be it's going to be a constant multiple, so it's going to get, as one gets bigger, the other is getting bigger, or as one gets bigger, the other is getting smaller. Traditionally, we're going to use a constant k to represent this constant of variation, or it's also called the constant of proportionality. So anytime you see a variation problem, the one thing you're going to have to do is translate it into symbols, and then symbols are going to involve some constant, a lot of times k. And your job is going to be to find out what k is to identify the appropriate model. The first variation that we're going to look at is what's called a direct variation. And this one and variations can involve just any powers of x. So y is going to vary directly with the nth power of x. Y is directly proportional to the nth power of x, mean the same thing. Both will be there. And to translate that means y is equal to our constant k times x to the n, again, where k does not equal 0. The next one we have, so you have the direct variation. Now we have an inverse variation. Again, the ways that you can say it: y varies inversely with the nth power of x, or y is inversely proportional to the nth power of x. What that means is that y is going to equal k divided by x to the n power. And again, where k does not equal 0. So anytime when you're dealing with a direct variation, it's going to be k times x to the n. We're dealing with an inverse variation, it's k over x to the n. The other ones you have are joint and combined variations. In a joint variation, what that means is that y is going to be varied jointly with x and w. What that tells us in this case is that when you're dealing with a joint variation, it's always going to be two or more direct variations. So in this case, when it says y varies jointly with x and w, you know y is going to be k times x times w. Direct variation with each. In a combined variation, it won't say combined. You'll see both in there. So it'll say y varies directly with x and inversely with w. So y is going to be k times x over w. Let's take a look at a couple examples. In the first example, we have v varies directly with the cube of r. And we're told that v equals 36 pi when r equals 3. So in terms of the variation, y varies directly with the cube of r, or v varies directly with the cube of r, I have v equals k times r cubed. And now I have to find out what k is. So I'll put 3 in for r, 36 pi in for v. So I get 36 pi equals k times 3 cubed. So that's 36 pi equals 27k. And so k is going to come out to be 36 pi over 27, which reduces to 4 pi over 3. So in this case, our model for this situation is v equals 4 pi over 3 r cubed. In our second example, f varies directly with m1 and m2 and inversely with d squared. And again, we're told f equals 20 when m1 is 8, m2 is 16, and d equals, that's 0.4. So putting that into our symbols, f varies directly with m1 and m2, so it's k times m1 times m2, inversely with d squared. That's why we're going to be divided by d squared. So it's f equals k times m1 times m2 divided by d squared. And now plugging these values in for f, m1, m2, and d, I get 20 equals k times 8 times 16 over 0.4 squared. So 20 equals 128k over 0.16. Multiplying both sides by 1.6 to get rid of the fraction, I got 3.2 equals 128k. And so k equals 3.2 over 128, which that does reduce to 1 over 40. So I know k would be 1 over 40. So when I put 1 over 40 there, that would end up being, our mathematical model would f equals m1 times m2 over 40 times d squared. That does now conclude the video dealing with variations. If you have any questions with those, make sure you note them and be sure to ask them. So with that, this concludes the skill review videos for pre-calc, and we'll look forward to seeing all of you in class.